Now we want to apply the ideas of oxidation numbers to actually study redox reactions. So now that we know how to assign oxidation numbers, we want to apply them, right? We want to be able to, the whole point was we wanted to identify reduction oxidation reactions. So if I look at this case, this was something that I said I would know, I could see things are changing cations, things are becoming ions or not becoming ions. So I want to be able to look at it and know what is being oxidized and what is being reduced. And so the process there is always going to be, I'm always going to start out with by, assigning oxidation numbers. And so in the case of this, I only have ions or neutral species. So my oxidation numbers are going to follow directly from the charge, right? Nickel 2 plus has an oxidation number of +2. Chromium solid is elemental, so it has an oxidation number of 0. Then, once I assign oxidation numbers to each atom type on each side of the reaction, now I can look at changes in oxidation numbers across the reaction. So nickel goes from +2 to 0. We can see it's +2 on the reactants, 0 on the products, whereas chromium goes from 0 to +2 as it goes across the reaction. So we can see there's this change in the oxidation number as I go across the reaction. I'm comparing reactants to products. Then if I look, I can see that nickel, that's a decrease. +2 to 0 is a decrease. Chromium, 0 to +2 is an increase. A decrease in oxidation number is reduction, and an increase in oxidation number is oxidation. You can see for reduction, there was a gain of electrons. Oxidation is a loss of electrons. Oil rig, Leo Ger, we want to be remembering those things. And so just like we assign oxidation numbers to each atom type, individual atom types are always going to be associated with reduction or oxidation. So whenever we're faced with figuring these things out, what's oxidized and what's reduced, we're always going to look to compute oxidation numbers and then look at how they change across the reaction. One final piece of lingo to add is the idea of agents. So an oxidizing agent and a reducing agent are the reactant that causes that particular process to occur. So previously, for example, in this, we can see that the zinc is losing electrons. So it's losing electrons, it's therefore oxidized, and the copper 2 plus is therefore reduced because it's gaining those electrons. So we can think that because the copper 2 plus is reduced, that's kind of the perspective of what is the copper doing. We can switch it to think, well, what is the copper causing to happen? And it's causing oxidation, which means it's the oxidizing agent. So by undergoing reduction, because the copper 2 plus is reduced, the other reactant has to be oxidized, meaning copper 2 is the oxidizing agent. So this agent terminology usually kind of has more broad appeal in the same way that we would talk about something as like it's a strong acid. So something that like is a good oxidizing agent. For example, copper 2 cations are pretty good at causing oxidation. They cause other things to oxidize. So it's kind of this idea of like, how can I use it? So it is specific, can be specifically applied to a chemical reaction, but it also kind of describes tendencies. So in this particular reaction, zinc is doing something, copper is doing something, but in general, copper 2 is a good oxidizing agent. If you put copper 2 cations into a solution, they tend to cause oxidation because they want to reduce. So we can put this all together, get all of our lingo in the following reaction: what is oxidized and what is reduced? What is the reducing agent? What is the oxidizing agent? If we look, we can see this is a combustion reaction. So we do know off the bat that it is reduction oxidation. So there's going to be something that's oxidized and something that's reduced. But it's not going to be it's not easy to identify what is what in here. So I have CH4, I have O2, CO2, and H2O. And so the first step is always going to be assign some oxidation numbers. Get oxidation numbers for each atom type on both sides of the reaction. So we can see, O2 is elemental, it's 0. In all of the species that hydrogen is in, hydrogen takes the +1, and so the other species just takes whatever charge makes it neutral, and our carbon is +4, and that's CO2 to balance it out. So we can compute all of our charges and see all the oxidation numbers for every atom type on both sides of the reaction. So once we have all those, we want to look at changes in oxidation numbers. If we look, carbon is -4 to +4. That's an increase. Hydrogen goes +1 to +1. That's no change. And oxygen goes 0 to -2. That's a decrease. So we can see that increase in oxidation number for carbon, that means it oxidized. decrease in the oxidation number of oxygen means that it decreased. Okay, so that means the carbon atoms were oxidized and the oxygen atoms were reduced. Okay, so carbon's oxidized, oxygen is reduced. You'll see we assign that language to a particular atom type. The next question was the agent question. And so in that case, we want to then look at assigning particular compounds. So we can see that carbon was oxidized. So that means the molecule that carbon was in this case, the CH4, is the reducing agent because it made the other thing do reduction. O2 is then the oxidizing agent. Okay, so oxygen was reduced here, but the O2 molecule was the oxidizing agent. This right here is actually where all of this language comes from. O2 is a really good oxidizing agent. Oxidizing meaning react with oxygen. So one of the things, it's very confusing, I know. Reduction being gain is on face confusing. But it all comes from the idea that oxygen is, people figured it out before they knew what was going on, that it was reactions with oxygen. So O2 is the oxidizing agent. So one of the ways you can always check yourself is O2, are you saying O2 is the oxidizing agent? That's a place you always want to be. And, you know, and always reactants that contain those corresponding atoms when we're looking at agents.
Another video down so far. No questions for participation 11.4. Maybe the next video. See you there.